We are here with Dave Silverstein, the Director of Channel Marketing for Crestron Electronics. How are you, sir?
All right, how are you today?
Doing good, doing good. We're sitting here in the Crestron booth at InfoComm 2014, talking about education, talking about what Crestron can do for education spaces. One of those things is the collaborative classroom, right? The idea that, let's take the huddle space idea, right, where you've got interactivity. You have the ability for 2 or 3 or 4 people meeting in a meeting space to share information and share ideas. Let's move that into a classroom, right? Let's give the students the ability to do just that. How does Crestron do that?
Okay, so the first thing we have to do is look at the collaborative classroom. And one of the misconceptions is we just take a bunch of huddle spaces and drop them in the classroom. The collaborative classroom starts with the concept of flipped learning, which is the way you change the education program.
Okay.
So what happens is you record the teacher's lectures and you make them available, and the students watch that as homework. So then the traditional things that the students would do as homework, in other words, going to the library, working on their projects, those kind of things, they actually come into the classroom and do that. So in today's world, when you come in the classroom and you're working on your project, you're not bringing soapboxes and diorama pieces anymore. You're bringing laptops and phones and research pieces. So you need a place to sit and collaborate with your classmates to create your ultimate project, whatever it is. At the same time, the reason it's a collaborative classroom is the teacher is actively involved.
Yeah.
So the teacher needs to be able to control each one of those student hubs, if you will. The teacher also needs to be able to take content from one group that's working on one thing and bring it over to another group to show the other group what's going on. The teacher needs to be able to take the assignment and put it to everything in the room. The teacher needs to be able to bring one group or all the groups onto the main display and all displays. They need to be able to annotate and make notes and show everybody what's going on throughout the process, because the whole concept of bringing that collaborative learning into the classrooms means the teacher is now going to interact with the students as they work on their projects with all those different spaces. So it's not just dropping a bunch of huddle spaces in the room, it's a much larger solution, and it's based on the way education approaches the project. That's really what drives the collaborative classroom today.
Okay, so that really great ideas. How does Crestron make that happen? I mean,
Sure.
how do you guys, as a company, go into a classroom or go into an education or an administration and say, these are great ideas that other schools are doing, the flipped classroom, here's how Crestron can make that happen for you guys?
Sure. So let me get to how Crestron can make that happen, but the first thing is, in most of our instances today, it's not about us going in and saying, hey, you need a collaborative classroom. It's about the educators within the organization saying, we are moving to a flipped learning model. We need the technology in the room to address that.
Yeah.
We already know that class scores and education scores are going up because of people that are using the flipped classroom model. We need to be doing it in our school. AV guys make that happen. That's where we really get involved. So the beauty of it is when Crestron comes in, whether we're using our connect-its on the table so students can come in and connect via wired, or air media so they can connect wirelessly, we have a great opportunity for everybody to connect in any way they want. Of course, digital media becomes the infrastructure of that whole thing, so I bring it back to a centralized switch. Now everything in the centralized switch dictates what appears in each individual space, and then we move to our V15 and DGE2, adding the annotation portion so teachers can control the whole thing. In most cases, classrooms are looking at either wireless touch panels or iPads as the teachers control, so the teacher can be moving around the space and at a moment's notice, as something happens with a certain group, they can grab something from another group or take that group and push it somewhere else. So it's very interactive as it happens. It's not a planned, structured thing as far as how that interactive learning occurs. So, and the real beauty to it is what they've done now is that they've taken technology from the background of the classroom and education to the foreground of the education environment. It has to be there. It's part of the solution. It's part of what's raising the test scores at the end of the day. So it's really part of the overall teaching curriculum, not just something that's supporting and helping.
And you guys are helping raise those test scores, which is kind of cool.
Absolutely.
I used to say, so they have said, let's go with this. Let's go with this great project. One of the neat things that you guys have done over the last year is let's call it a non-programming classroom. It's an idea where you set up the infrastructure, you lay out all the Crestron components, and then it's more configuring rather than a traditional programming sense.
Yeah, so for the collaborative classroom, which is still let's not call it cutting edge, but it's still unique in most of the educational spaces. Most people are not building new buildings that are all collaborative in nature, but I'm sure in the next 12 to 24 months they're going to start doing that. In the meantime, there are plenty of still lecture-based classrooms that exist. As a matter of fact, in the AV world, where it used to be, oh, I had 10 or 12 classrooms that had AV components, now you're putting up a new building and you've got 200 or 300 rooms that are all traditional AV control. You just can't spend the time or the effort to program 200 rooms. They're all going to be the same or similar enough. Yep. And at the same time, they need to be the same or similar enough for the teacher to be able to operate it. Yet everything needs to be a little different for various classroom reasons, whatever they are. So the DMPS 100 now, with the no programming package, allows you to take a DMPS 100, which gives you all your audio and video inputs, as well as your microphone and all those pieces. Digital media, of course, on the output to run a single display. We add air media to it so they can bring in their wireless devices and connect wirelessly as well. And then from either a standard Crestron touch panel, iPad, Android device, computer, you can go in and actually commission the system is the best way to put it. So you go ahead and you select your sources, you type in the name you want, you pick the icon or the image that you want selected for it, you go to the display side of it, and then on the display you can name the display appropriately, but more importantly, now you can pick the actual driver that controls the display. So a Crestron connected device, for example, there's over 2,000 projectors in the library of Crestron connected devices. Choose Crestron connected and we're controlling that device and running it. Maybe you just have a flat panel and you want to use CEC control. You select CEC control and now I'm controlling it right through the same HDMI cable that's plugged into the display. And of course 232 is always one of our favorite ways. We pick from our 232 list, slap it in, away I go. So now, if nothing else, I can send my student help out, and by pushing a couple of buttons in 15 minutes they can have a running operational room. And the beauty of it is, I have a projector problem, I want to change a projector in a room, I can send a technician out there to change the actual system to be controlling the new projector that I put up in a matter of minutes, keeping my classes running.
Yeah. The one thing, though, I want to touch on, because when you guys released this, there was pushback, right, from traditional programmers, from your CSPs. Yeah. This does not replace them.
Absolutely
It does not replace the traditional CSP or even folks who have spent years and years and years getting silver or platinum master level Crestron programming skills.
Not in the least. What this does now is, now when I have those 100 rooms, there are always 10 or 12 offshoot rooms that do need special programming, and allows the basic rooms to be focused on by the people that are doing the basic stuff. And now our advanced, sophisticated programmers can really spend their time where they bring the most value and deliver the most good to the organization to really do that true custom stuff that we need in an auditorium or a special breakout room or a collaborative classroom, for that matter, where things are still being defined and different teachers want to collaborate and teach a different way. That's really where our high-end programmers have the best value, and that's where they're building the future for what those next classrooms are going to look like.
Absolutely. All right, Dave Silverstein, Director of Commercial Development. Thank you, sir.
All right, thank you.
All right, we are here now with Justin Keenen from Crestron Electronics, part of the DM program.
Thanks for having me, Tim.
Absolutely. And Tom Barnett, part of the Media Marketing Department.
It's nice to be here, Tim. Thanks.
Real quickly, Justin, congratulations. You are the recent recipient of the Young AV Professionals at InfoComm.
It's less than 24 hours old. Thank you.
Yes. How was it?
It was a delightful event. We had a nice banquet. Maybe the first okay catered steak I've ever had in my life. So it was a nice surprise and a lovely event.
Yes. All right.
No chafing dish here?
No chafing dish?
What?
No chafing dish involved in the production of your steak?
I don't know. I don't know what that means.
A chafing dish. It's a dish with the... Never mind. All right. Let's talk about 4K. Justin, as part of the head of the DM product line, one of the things that is all over this wonderful Crestron booth is not 4K ready about DM. It's 4K already. And actually, if you're on social media, hashtag 4K already. What I find interesting in that is the fact that the DM switchers and the chassis and everything like that, you guys built that not just to handle 720p, not just to handle 1080i or 1080p. You guys built it to be adjustable as the resolutions expanded. Was that forward thinking, or was that just, hey, we got lucky here?
I'll tell you, I'm always happy with how impressed people are with that. But in fact, that's one of the easier bits of this job.
Oh.
You know, a lot of running a product line like this is about having to predict the future, having to make sort of big bets on some of those predictions, and hoping they go right. Meanwhile, what I'm building here is a digital communication system. It moves bits around. You know what those do is get faster over time. So back in 2009, when we started shipping this thing, we didn't know, 4K is going to be here, and it's going to be 4096 by 2160. But we knew there's probably going to be something that's an awful lot faster than now. So we just overbuilt it, is what it comes down to. So the DM chassis themselves are built for flexibility, are built for speed, with that promise that any format that comes out down the road, we're going to be able to support that. Get a new input card, get a new output card. We got demand for SDI one day. We built in SDI input cards. HD-based T replaced our original category cable solution. And so digital media is about that flexibility. So the speed itself is actually sort of the easiest part. Of course that was going to get faster.
Yeah. Real quickly, because you mentioned the resolution, let's not gloss over the fact that quote-unquote 4K is not always 4K.
Sure.
And that's one of the interesting things about Crestron is not only if you've messed with DM and you busted open Toolbox and some of the DM tools, you have all this EDIT information. Mm-hmm. Talk a little bit about the fact that quote-unquote 4K and how you guys manage all the different resolutions inside that one ubiquitous title.
So in terms of EDIT, I describe that to people. I try and get system designers on board to understand that EDIT is a system design issue. Mm-hmm. The way I like to put it is you guys are out there in the trenches designing these incredibly sophisticated, incredibly expensive video systems. You know, these guys might build a $500,000 video distribution rig. And then the most popular source that gets connected to that is some idiot's laptop full of malware, full of whatever the IT department put on it. He doesn't know how to use it in the first place. And he's going to presume to make that an integral component of this beautiful thing that you, the system designer, have created. You have exactly one mechanism of communication with that device that this Yahoo brought in, and that is the EDIT. Yep. So you have to think about that as a system design problem, just as important as should I use an HD-based T transmitter or a fiber transmitter. It's that crucial in that level of a decision. So for us, the idea is to build EDIT management tools that are sophisticated enough to give you total control over that user experience, but while making it easy enough so that I don't need you to go to a 4-year degree in EDIT management in order to handle that.
God help us if they ever have to develop a 4-year degree for EDIT.
I've actually got a curriculum written already.
Shush. Tom, one thing that's been interesting over the last few years is, let's be honest, Crestron has kind of gotten beaten up over digital, right? First, you guys were too early. Then you didn't know what you were doing some of the time. You have stayed consistent and have just walked the walk. You've done some of the things that other manufacturers haven't done. You've gone to the Plug Fest, right? You've taken the DM chassis and you've said, okay, how's this stuff work? You know, you've built very expensive labs to make sure that your digital infrastructure works. How do you get the message out there? You know, besides this very nice, wonderful booth, how do you get it out to not only the consultants and the integrators, but also to the technology managers and ultimately to the end user?
Well, for one thing, we appear on AVNation podcasts.
Well, there's that.
Every time that we're invited.
Okay.
So the stories that we need to get across really are helping people think about the problems that they're going to have a little bit down the road. As Justin says, you know, we're making bets in some cases, but they're really well educated, and we have a long track record, and we can sit there and think about what those bets should be, while people in the technology management world are also having to put out fires in their rooms right now, today, every day. So a good example of this is, you know, when you were talking before about it's not always 4K. You know, a fair amount of what's going on in these systems today is that you have devices like a Dell laptop that's 3200 by 1800, or you have a MacBook Pro with Retina and it's 2560 by 1440, or 2800 by or 2080 by 1800. Those sources, you know, the people coming into the spaces are going to expect what they always expect. The job of this whole $500,000 EV system is to take exactly what I see on my laptop right now and make it show up there for those other guys too.
Yes.
I don't want to see different things in different places right before I do my presentation, resolution changing all this business. So while the big marketing hook name is 4K, rolls off the tongue, Sony's printing outside the boxes, things like that, really a lot of the times you're worried about the 2.8K and the 2.5K. So some of that we can get across places like this. Some of that's about building into our education programs. Some of that's about having people in our organization that go to the technology managers. We've got a market development team that spends their time talking to people who are the end technology customers, not the dealers who have quotas they need to hit and things like that.
What's interesting about that, because as some people may know, I came from the world of education, right? Mm-hmm. That was my introduction to Crestron, was one of those market development managers who walks into my office and asks me what I knew about Crestron, and at the time it was not a whole lot. We didn't have a whole lot on our campus. Those frontline people that work for Crestron are crucial to building that relationship. How do you get them prepared? I mean, is it educating them, bringing them into events, whether it's at your headquarters in Rockley, or is it their local offices? How do you prepare them to send them out to talk to guys like technology managers?
Yeah, so we really value that direct relationship, obviously, which is why we've invested in having these market development managers. But it doesn't do a lot of good to have somebody on staff unless they know what they need to be teaching people about. So a good example is yesterday we had a 5-hour sales meeting where our CTO, our CEO, Justin prepared some content. I'm there. Dave Silberstein was there. And not only the market development managers for education, but also for government, and then all of our general sales team. This is a big annual time to talk about here's where we're at, here's the direction we're setting at the show. And then also quarterly, there's a meeting in each region, in our regional office, where we get everyone together. And in fact, our CEO personally goes to those meetings in every region, every quarter, to make sure that he can hear directly back from them what needs to be done. And that's our opportunity to make sure they've got whatever information we have about the new technology to get in their hands, so that as they're moving out, that's augmented with, of course, you'll send around information via email. You'll make PDFs that they can use and things like this. We'll make a video that you can watch about something for training. But a lot of it is that face-to-face time and interaction with the people who are doing the development of the products.
Justin, one thing let's talk about for a second is 4K and beyond, right? I mean, we talked about the fact that you guys don't have a crystal ball. So what you're building is the infrastructure to make sure that you can take the next step. What do you see happening with not just 4K, but the next resolution, and going forward in the world of transmitting high definition or higher definition video and audio?
I wouldn't be surprised in the longer term to see some move towards more compression more of the time. We're living in a world right now where pixel densities are going up, and along with that, I don't know if you're familiar with or seen any of the early demos on what's called high dynamic range imaging, but what we're talking about is more bits per pixel.
Yep.
So we're adding more pixels and we're making bigger pixels, and that creates this exponential curve that, frankly, digital electronics are good at.
Yep.
The cables are analog things. The infrastructure is not going to be able to take that kind of growth rate, and so it's not any sort of concrete plan. It's really speculation on my part, but I would predict an industry move towards adopting some of these very lightweight, very ultra-low latency compression technologies in order to be able to manage that.
Does that also mean that you see more adoption of fiber and getting rid of copper in general? Because if the copper can't handle it, then
I have until recently when I stopped, I have been betting about the end of copper for 10 or 15 years. There was a time when 100 megabit Ethernet was impressive, and we said, oh, gigabit, I don't know if we can do that. And then next thing you know, Apple has a $1,000 gigabit Ethernet card, and we all went, holy cow. And now gigabit Ethernet is a $20 commodity card, and 10 gigabit Ethernet is bordering on commodity devices. The guys that do the DSP magic that make copper high-speed Ethernet work, I've quit betting against them. So yes, of course they're going to run out. There's no way they're going to go beyond 10 gig until one day they call us up and they're like, hey, we got our 40 gig stuff. And I go, what?
Or 100 gig.
What? I have to think that fiber is going to become more ubiquitous to help with that, because fiber does have a much easier time reaching those ultra-high bandwidths. And that's what we see in the big data center telco-type installations and industries. But there it's not only about data rate, but about distance, when you're building telco infrastructure. So it's a little bit we'll see. I do predict a growth of fiber, and yet I quit betting against those copper maniacs a while ago.
Tom, real quickly before we let you guys go, if there's one or two things that you wish people could know about 4K or know about Crestron, if they've either never heard the name or just are starting to get introduced to it, what would it be? What would be like the one or two things as soon as you meet someone and they say, "What do you do?" and you say, "I work for Crestron." What does that mean? What would it be?
Well, at the end of the day, the reason that Crestron is here is to help people solve problems that relate to technology in their life. So it's a very simple, little simple way of thinking about it. Hey, ever go into a meeting and had that meeting start 15 minutes late because people were messing around trying to get their signal up on the screen? Sure, the resolution might be higher, and so the 4K message, that's really for the technology professionals, but that general word on the street is, hey, you can make it as simple as walking into the room, having the room know that you're walking in there, so it adjusts the HVAC to the right point, have that room know that you're walking in there, so it's a time of the day where you might like the shades open, touchscreen wakes up automatically because of the motion detector, and it says, hey, what are you trying to do? You press one button, and that one button can get you into that meeting, 2 minutes from the time that you thought about leaving your office to walk down the hall to be down there, rather than you and 15 people are sitting there for 15, 20 minutes while somebody figures out the whole muck mess that you've got in that room.
Tom is super fun at parties. When people ask me, I say, "Do you ever watch MTV Cribs?" And somebody's like, "Check out this touchscreen on the wall. It controls my hot tub." I'm like, "That's us."
But they're both good answers. I mean, one is definitely you and one is definitely Tom.
It depends what kind of party you're at.
Well, exactly. All right, guys.
Hot tub party.
We're going to go to the lab, correct?
Let's do it.
All right. Tom Barnett from Crestron, thank you, sir.
Thank you.
Justin Keenen, thank you. And again, congratulations on the Young AV Professional Award.
Well, thank you very much. I'm hoping to win the old AV Professional Award soon.
You have a few years for that. Great, thank you.
I'm Justin Kennington with Crestron. I'm here in the Digital Media Lab section of our booth, here today to talk about some of the challenges of 4K and how digital media helps solve them. What you can see here on this television screen is a red ray connected directly via HDMI to this Sony X850 television. And you can see this is not a working system. We're seeing flashing, we're seeing dropouts, we're seeing a very unreliable video performance. Obviously, this would be unacceptable in the field. Not only that, but you would have trouble analyzing this problem in the field and understanding what's going on. At best, you might reboot a couple times, change a few cables, and hope for the best, but you'll be left without a robust system that you can feel confident in. So today I want to look at some of the analysis tools that we use in the Digital Media Lab to help explain what's going on here and then demonstrate how digital media can fix it. This instrument is an Agilent Technologies digital oscilloscope. This particular instrument is capable of operating up to around 25 gigahertz. This is a very serious piece of hardware, worth about $250,000. So I want to show you what this looks like when I connect the oscilloscope directly to this red ray player. Now what we're looking at here is called an eye diagram. You can see there's these colorful lines. Each one of these dots passing through here represents a single bit, a 1 or a 0, passing through the receiver inside this oscilloscope. You can see there are bright white areas, more green areas. Think of it like a weather map. There are billions of bits overlaid on top of one another here, where you have a lot of bits, they're very bright areas, and fewer bits are in these dimmer and blue and green areas. What you see in the middle here, this feature is called the HDMI mask. That's really the definition of the HDMI specification. Think of that as the keep-out zone. As long as your bits stay out of the mask, then you can trust that your receiver is going to reliably understand the digital signal. When bits get into that mask, that signal might be now misinterpreted. You're going to have bit errors. 1s turn into 0s, 0s turn into 1s. You might get some sparkling. Worst case, you might get dropouts or even no image. And that's what we've seen here today. So when we look at this image, we can see these spots highlighted in red here at the corner of the mask indicate places where bits are in the wrong place and might be misinterpreted by the receiver. And that's borne out by the performance we saw on this television with the flashing image. So now I want to show how digital media, using its digital conditioning capabilities, cleans up that signal and gives you a much better looking mask. I'm going to connect the scope to the output of the digital media room box, and I'm going to connect the output of the red ray into this digital media switch. So I'm now passing from the red ray through the DM switch, through 20 meters of 8G cable, and into this 4K room box. Now if I clear my display, what we'll see building up is a new HDMI eye diagram that shows an extremely clean signal. You can see lots of black area around the mask. That's margin. That means you're going to have a robust system out there in the field. Now let's see if this has fixed the television. I'll unplug the scope, from this room box, and I will connect the television directly. And now what I expect to see is a clean, working 4K signal with no dropouts, no performance issues, and a reliable performance. Today I want to show you some things about HDBaseT cabling and introduce our new 4K cable. Now the HDMI specification allows you to have 1 pixel error per billion pixels transmitted. HDBaseT says that any Cat6a or better cable can transmit 4K up to 100 meters. Our test results here that I'm going to show you today demonstrate that that's not exactly true. So here today I've put together this set of Valens reference extenders. These are the devices that Valens themselves provide when a manufacturer wants to build HDBaseT devices. So these are sort of the golden reference standard for how to do HDBaseT. I've connected them up with this piece of Belden 10GX cable. Now this is a nice Category 6 cable. If I were building a 10 gigabit data center infrastructure, I wouldn't hesitate to use this cable at all. Plus it meets that HDBaseT specification. It says Cat6a or better. So here today I'm actually hooking up to this Quantum Data QD980 HDMI analyzer. It's going to send signals at 4K through this cabling system and measure the rate of errors that come through. Now I remind you, the HDMI specification allows 1 error per billion pixels transmitted. And what we see here as the test starts up is this cabling system is actually failing that specification relatively dramatically. We're seeing error rates of over 200 errors per billion pixels. Now that doesn't sound like a lot, but that's going to lead to the kind of failures that you might have seen in our other demonstration where we show flashing images due to too many pixel errors. That's not what we want. We're afraid this is not going to be a robust system, and we need a way to improve them. Now I want to compare this to the performance of digital media and our new HDBaseT specific 4K DM cable. This is another 100 meters of cable that we've custom developed to meet the specific needs of HDBaseT and 4K at 100 meters. So I'm going to disconnect the Valens extenders from my quantum data analyzer, and in their place I'm going to connect this digital media 8x8. So now the quantum data is feeding its analyzer output into this 8x8's HDMI input, and then we're transmitting that through this 100 meters of DM4K cable into our digital media HDBaseT receiver, feeding that back into the quantum for analysis. We should see results coming up now, and what we're going to see is that this cable is capable of transmitting 4K at 100 meters with 0 pixel errors. That's a unique feature among cables in this industry, and that's why we've developed it specifically for use with digital media and HDBaseT.